Okay, let's discuss about direct memory access DMA. Right, 8237 chip is used as a DMA. Now first question is why we need this DMA, right? So if you consider a normal scenario, you are having a processor, right? Suppose in our case it is 8086 processor. You are having memory and you are having input output. Now suppose I am having 1 byte in memory, and as an input output device, suppose I am having a printer and I want to print this 1 byte. So how that process occurs? Now first processor will read that 1 byte from memory, so read cycle will be there. Yes, after that your 8086 will get that 1 byte and it will give a write command to your input output device and your printer will print it. So a small task of printing 1 byte requires actually a 2 byte. It should be a single byte operation, right? We want that it should completed in one clock cycle, but instead of that it gets over in two clock cycles. So that is the problem, right? So that's why we require DMA. Now why this thing happens? Because all the control of system bus is with your microprocessor only, 8086 only, and no one can have the access of it. Your memory can't write something directly to input output, that is not possible. So that's why every time if you want to use your system bus, you need to involve your microprocessor, and that's why a simple task of 1 byte transfer require 2 clock cycles. So if you want to make it faster, you require direct memory access, DMA. So that's how DMA comes into picture. So what DMA do? DMA is doing nothing, but what it will do, it will take the control of system bus from the microprocessor, and using this DMA controller you can now directly transfer your memory to your input output device. So the same task which was previously done by 2 clock cycle now gets completed in 1 clock cycle, and your processing will get faster. So that is the advantage of DMA. I hope this is clear. Yeah, so now let's go further. Let's revise the basic stuff. What is DMA? It is a direct memory access. Yeah, it is a direct memory access. It sends data directly between memory and input output. You don't require your microprocessor in between. Now, is it double fast or extremely fast? It is not only double fast, it is extremely fast. Now why, that will study later on, but like first thing is it transfer in one cycle instead of 2 clock cycle, that we have already discussed. The another advantage is your DMA controller is hardware based. It is a controller, right? It is not software based. Now your processor will work in a context of software based coding, so we need to give instructions and it will copy the content from your memory to input output. So all controls will be used, read control will be used, write control will be used with instructions. So when instructions are comes into picture, you need to do fetching, you need to do decoding. As far as DMA is concerned, you don't need to do any kind of fetching, any kind of decoding, and that's why it is actually faster. Okay, now let's see the working of DMA, how actually DMA process, right? So first thing starts with processor. So first processor send something to DMA. What it sent? There are two registers with DMA: current address register CAR and current word count register. So there are two registers. So your processor will tell your DMA that you need to transfer particular content which starts with this particular address and it contains this number of bytes. So your now DMA knows that I need to transfer this much data from my memory to input output device. Then DMA waits for input output devices. So it first check that your input output device is ready or not ready. Yeah, so how it will get to know that? As you can see over here, you are having input output device. Your input output device will actually having a signal called DRE1, D request 1. So it is on, normally keep always on. So suppose you are having a printer, when it gets started it will make it 1. So anytimes you need to take the services for printer, you just need to see that printer is on or not. So same way your input output device send this DRE, always make this DRE is equal to 1. So your DMA controller will get to know that it is 1 or not. If it is 1, yes, so your controller knows that now your DMA controller knows that your input output is ready. So what it will do, it will send the whole signal to your processor, right? So it will make your processor into hold, and it will make hold equal to 1. So once that is done, your processor release your bus control, right? As you can see over here in the diagram, it release the bus control, and the switch will now join to DMA controller. It will simply a switch which will work like, if it is off, the switch is on and it control is given to processor. If switch is off, it is given to controller, and it is the bus control will given to DMA controller. So what happens is, once the DMA controller sends the hold signal, your 8086 will release the system bus, and it will acknowledge the controller that I have released the bus signal, now you can start your work. So HLDA signal will be sent to your DMA controller by your microprocessor, and DMA controller now get to know that now I am having the full access of my memory and input output, right? So now it will take the control of system bus, and it can start working with your memory and input output and transfer the data. Yes, get it? Yeah, clear? Then what happens? DMA waits for input output, DR equal to 1, DMA to processor, hold equal to 1. This is clear. Then processor release the bus control, hold and to DMA. This is we have already discussed. Now DMA to input output. So it will send the acknowledgement to your input output device. So DMA controller will send the signal to your input output device that now you are ready to serve, and the data will get transferred. Once your full data will get transferred, your DMA controller will tell your processor that I am done. So how it can say that? By simply making hold equal to 0. So this is what the full procedure of DMA controller. So as you can say, at the end, DMA to processor, hold equal to 0, and your process will get done. So this is how your DMA controller works. Just for the sake of revision, let me revise it again. How it occurs: first, microprocessor tells the assembler, microprocessor tells your DMA controller that this is the starting address and this is the ending address. So total number of bytes that you need to transfer, right? Okay. Once it is done, DMA controller will check with DR EQ with input output device. Once it is okay, it will send the hold signal to your microprocessor. Microprocessor will release the system bus. It will tell your DMA controller by sending HLDA signal, acknowledgement signal. DMA controller will send the signal to input output device, that acknowledgement that now we are ready. They will transfer the bytes. Once the byte gets transferred and it is done, your DMA controller send the signal to your processor that hold equal to 0. So now I have releasing my system bus. Now you are having the control on system bus, and you can continue. This is how your DMA controller works. Okay, many of the time it is referred that DMA is twice the faster than the normal processing. Is it true? Yeah, it is true, right? But not only twice, it is actually quite very more faster than the normal processing. How? It can reduce the cycle to 1 instead of 2, right? So we can say that it is already double. But it is only double? No, it is not the case. Why? Because just take the case that, see, if you want to transfer something from your memory, right, to input output, there must be some code which is running in the background because your processor is doing this stuff. If you want to do any task from processor, you need to write down code, right? Coding is needed. So suppose if we take a simple small program of code, as you can see, if you want to read something from memory, this is my first instruction. If I want to write something to input output, I need one instruction. I need to increment the address, right, from next location. Now I need to fetch the data. Now I need to decrement the counter which I have used, that this much block is needed, and you need a loop. So every time to transfer a single byte, you need to perform these 5 operations if you are doing this by a normal processing. So suppose if you need to transfer 1000 bytes, you need to do 1000 into 5 times. That means 50,000 times fetch and decode operation, because for all the instruction you need to fetch the data, you need to decode it, you need to fetch, you need to decode it. Though it is a pipeline concept, we are having the pipeline in 8086, but because you know that it is a loop, so every time you are changing the value of IP, so your prefetch queue will get empty every time. So every time you need to do fetch and decode, fetch and decode. So Simple example, if you go for even 10,000 block 8-bit data, and if you want to transfer it from memory to IO, you need to do 50,000 times fetch and decode. This thing you don't need to do with your DMA. Why? Because it is a hardware base. So it is a hardwired logic which is fixed. So you don't need to run any software. You just know your starting address, the total size, and you need to perform the operation. So this full time will get saved. So not only your cycle will get reduced, but at the same time this fetching and decoding time will get reduced, and it reduce drastically. So that's how your DMA is actually make your memory transfer very fast. Now the final topic for DMA is modes of DMA. There are different modes of DMA. There are 4 different modes. One is block transfer, right? Cycle stealing, demand transfer, or hidden or transparent transfer. So now let's see one by one what is block transfer. Whatever we had seen in our previous sessions are block transfer. So what happens in block transfer? Simple. One block is given, you take, like DMA take the controls of system bus, it will transfer all the data and then give the control again to the microprocessor. So what will be the advantage? Transfer will be very fast. What will be the disadvantage? Now bus control will be taken by your DMA, so your processor will not having the control over system bus. Though your processor, if it want, it can take it back, but still it don't take. So normally processor need to be in hold situation for a long time. So that will be the disadvantage. So this is normally a block transfer mode, right? Second is cycle stealing. It is also called 1 byte transfer. So here what happens, once the processor saying that you need to transfer this block from memory to IO, right? What DMA do? DMA take 1 cycle, transfer the data, given control to processor. Processor use 1 cycle, given back to DMA. DMA again use 1 cycle, transfer the data, give it back to processor. So what happens? It is very slow. This is the problem, right? Because every time you need to perform 1 cycle, you again need to give it to processor. So actually you are using 2 clock cycles, same as the previous case. So it will be little bit slower, right? Advantage is your processor will not remain empty for full time. It will get cycles in between, so it can also perform some tasks related with system bus. Nowadays in normal all the computers, modern computers are using cycle stealing, because I hope you have experienced that when you put something to copy, right, and in between if you are watching the movie or something, right, you are able to do that. Why you are able to do that? Because 1 cycle is given to you also, so you can watch the movie and at the same time you are copying your data also. So that is because in the background they are using cycle stealing. So as we have already discussed in our previous session, though it takes 2 clock cycle, still it is faster than the normal processing. Why? Because here everything is done by hardware. No fetch decode operations need to be performed as far as software is concerned. So though it is slower than block transfer, but still compared to normal processing it is faster. And nowadays in all modern computers they are using cycle stealing. 1 cycle for DMA, 1 cycle for processor, 1 cycle for DMA, 1 cycle for processor. That's how it occurs. Now what is demand transfer? Demand transfer is not, no, actually it is not a mode, it is just a add-on feature, right? So here what happens, as we have already discussed in our previous section, that D request is always 1. Suppose my printer gets on, it always make D request 1. So if your DMA wants to access it, it can access it at any point of time. Here that is not the case. Every time printer wants to take service, like if your printer wants to get ready, it will send the 1 again and again. So based on the demand, D request will get 1, otherwise it will become 0. So on demand request. So based on the requirement of the hardware, it will become 1 and your DMA will serve it, otherwise it will not serve it. So that is how your demand transfer works. Get it? And the final topic is hidden or transparent transfer, right? So here what happens, like as we have seen in previous case, that what happens, how DMA works. Once the processor tells your DMA that you need to transfer this byte, DMA checks the input output device. If it is ready, it will send the whole signal to processor, right? Here your DMA will not send the hold signal directly to your processor. It will observe the processor. If your processor is idle, if it is free, then only it will send the hold signal. Otherwise, your DMA will wait. So what DMA is do? DMA will be intelligent enough that processor is doing some important task and I should not disturb my processor right now. So DMA will wait. And once your processor is gets idle and free, then only it will take the system bus from the processor. So it will help processor as well as itself also. So that is how this hidden or transparent transfer will work. So this is it as far as DMA controller is concerned. 8237 chip is available to implement your DMA direct memory access. Okay, thank you.